All right, I want to quickly go over pages 23 and 24. That's Chapter 15 homework, parts 3 and 4. I did show you this pretty much yesterday in class for you to check your work. I particularly wanted to check and make sure you're covering everything here on part B when it asks about you showing independence. I want you to show this. First of all, going to Whataburger, given that you are a senior. This is your conditional probability. And the reason I chose this version of the conditional is because that's what they had asked me there. So I already had that work. So that's why I chose this conditional probability. And because this is the conditional probability, then the one that goes with it for marginal is supposed to have the same first event. So since this says go to Whataburger first, then the other one should be go to Whataburger overall. So I actually want to see you write out this notation here and this notation here. You don't have to tell me it's from part A. I can see the work. All right, and then this one said they are not independent. The fact that you're a senior increases the probability from 0.36 to 0.53 that you go to Whataburger. This problem we talked about yesterday, I showed it to you. There were 3 parts to this here. You had dating somebody not from AHS, dating somebody from AHS, and not dating at all. So you had that for the male. You had those 3 things for the male. So the question was, given that you date somebody not from AHS, so let's find that. Not from AHS, males, so this is one piece right here. The dating not from AHS males, and the dating not from AHS females. So these are the 2 parts that go down here on the bottom. Here's the males, here's the females. And then, what's the probability they are a male? So that's the part that is on top. So that's overall 0.52. So again, I want you to show, for this test of independence, I want you to show this piece here. I want to see this notation. I want to see, here's the conditional. I kept that one because that is from the first part. So that's what I choose to write here. And then since this was male, then I did male overall, which was also 0.52. So they are independent. Given that you date somebody not from AHS, does not change the probability that you are a male. All right, and then I'm just going to go ahead and show you these ones real quickly because we are running out of time. I don't want to spend too much time on that. So this one was, given that you have high temperature, so that is high temperature with the flu, high temperature with no flu. Those are the 2 pieces that go down here on the bottom. And then the part that is on top is the flu part. So that's the 0.35 times 0.9. So if you have high temperature, there's an 80% chance that you have the flu. And then here is the earning with Republicans. And it said, given that you earn over $100,000, what is the probability that you are a Republican? So I have to put all of the earning over $100,000 on the bottom, and I have to put the Republican piece to that on top. So on the bottom is earn over $100,000 and you are Republican, plus earn over $100,000 and you are Democrat. So that's these down here. And then it's asking about the Republican piece. So that means that's that part on top. That makes it, if you earn over $100,000, that's 73.8% chance that you are a Republican. All right, now to the warm-up. Now, yesterday in class, we talked very carefully about this Venn diagram because this dog piece was 0.39 and the entire cat piece, the entire cat circle was 0.34. Well, remember that the problem said the dogs plus the cats should total up to 60%. Well, that caused a problem because 39% plus 34%, if you just added the dogs plus the cats, you got 73%. So dogs plus the cats double counted this section, so 13% got double counted. That's that overlap of dogs and cats. All right, so that's what this Venn diagram looked like. Okay, so we had that numbers once we did those numbers. Okay, so now what's the probability that it's neither a dog nor a cat? That is this little piece out here, the 0.40. What's the probability that you own a cat and a dog? That's that middle section, the 0.13 we figured out. Here is the one that gets missed on the quiz. So people, please pay attention to this. It says, what is the probability that a randomly selected U.S. household owns a cat if the household has a dog? If they have a dog means, given that they have a dog. So of the entire dog circle, which is 0.39, so of this 39% dog circle, what portion of that is the overlap, the cat and dog? The overlap is the 13% on top. Do not put the 0.34 here. It is not the whole cat on top of the dog, because then you're including the 21% of cats, people that have cats and not a dog. It's the overlap that goes on top, the 13% over the 39%. All right, here we've got this piece. Here's how this Venn diagram worked. You had company A, company B, and company C. And then it told you the amount from each one that was defective or okay. The defective component or the okay component. Then the question asks, so I'll let you kind of check your tree diagram there. Then it says, a worker at the manufacturing firm discovers a randomly selected computer chip is defective. So people, what that means is, given that you find a defective chip, so I need to put all of the defective chips on the bottom. And guess what? There are 3 of them. Some from company A and some from company B and some from company C. And here's what that looks like. So here is the company A defective right here. I just highlighted in yellow. Company A defective is the 0.10 times 0.04. Company B defective is right here in yellow, 0.20 times 0.02. And then the company C defective is 0.7 times 0.005. Check that, because 0.5% is 0.005. All right. So if that total on the bottom is 0.0115, and the question says, given that they are defective, what's the probability that they came from company B? So that means I want the company B piece on top. That is this right here. The company B piece goes on top. So that's your 0.004 over your 0.0115. That makes 0.3478. 35, about 35%. Chance that you came from company B if you found a defective chip. All right, now on this back. What's the probability that a randomly selected student is female? Okay, so that's just out of everybody. What's the probability you're female? So that's the females out of the total. All right, what's the probability that a randomly selected student, see, it's out of the total students. So out of the 331, what's the probability you eat breakfast? And that's the 191. Okay, now we get to some given that stuff. So, well, actually, here's one that has some overlap. Okay, so I've got overlap right here. It says, what's the probability that a randomly selected student, see, so we are still pulling from all students, 331 of them. What's the probability that out of all the 331 students, it is a female who eats breakfast? That's the overlap of females and breakfast, and that is this 125 out of the 331. All right, let's read D. What is the probability that a randomly selected student is female given that the student ate breakfast? See this? Given that the student eats breakfast, I'm telling you, it helps to write out the notation. So given that the student eats breakfast, so that is out of the breakfast eaters, and there are a total of 191 breakfast eaters. Then I want the overlap of female and breakfast on top. The top is always the overlap of those two things. So that's the 125 is the overlap of the female and breakfast right here. Okay, the next one is, what is the probability that a randomly selected student ate breakfast given that the student is female? So that is out of all the females, so that's out of the 199 females, what is the overlap of breakfast and females? And that's the overlap. So the overlap is on top. And so that gives you the 0.628. Now, let's go for this question, independence. There are multiple ways you can do this. Pick one. So I picked this one. Given that it's a female, so you just pick one of the conditional ones that you have. It doesn't matter. So pick a conditional. So I picked one of these conditionals that is already up here in the problem. So I picked, given that you're a female, what's the probability you eat breakfast? And so then that would make my marginal have to be this breakfast overall. Remember, the marginal is always the same thing as the conditional's first word, event. So again, here is the female and then the breakfast eating female, so that's 0.628. And then overall, that means your breakfast overall is 191 out of it. So that means, are they independent? They are not independent, because the fact that you are female makes it more likely that you eat breakfast. Because given that you're a female, you have a higher probability of eating breakfast. Other ways you could have done this, you could have done the conditional that says, given, use one we've got there. Given that you eat breakfast, what's the probability that you're a female? Because that is what it asks. That's the conditional up here in part D. If you use that one, what would the marginal be? It would be the first word here, overall females. And you would check and see if those are the same. So people could do different kinds. So on the quiz, You've got to pick one. So pick a conditional and then put the marginal that goes with it.